यस, गुड मॉर्निंग स्टूडेंट्स। देखिए, हम कल डिस्कस कर रहे थे कंजर्वेशन ऑफ मोमेंटम के बारे में और हमने उससे रिलेटेड 2 या 3 प्रॉब्लम्स कर ली थी। यस, राइट डाउन द नेक्स्ट प्रॉब्लम प्लीज। यस, लिखेंगे अ बॉडी ऑफ मास m1 is projected with speed v0 on a plane of mass m2 as shown. Find maximum height reached by m1 on m2. So what is the maximum height reached? You have to calculate this thing. देखो, this is the mass m1 which moves with v0 and this is m2. We have to calculate the maximum height reached by the m1 कि वो कितनी हाइट तक पहुंच जाएगा। देखो, when it starts moving तो it will move, और जब ये maximum height पे पहुंचेगा तो it will come at rest with respect to this, but at the maximum height both are moving with the same speed. Both are moving with same speed. So these two both are moving with same speed, that is v. Let's suppose. So here at the maximum height when it reaches, these two will start moving with the same speed because the m1 will come at momentarily rest. M1 will come at momentarily rest. तो मैं क्या कह सकता हूँ? If we observe, there is no external force is exerted on it and even there is no external force or the friction is doing any work. यहाँ पे कुछ नहीं है. So we can say directly one thing that one we can use the conservation of energy. If we use the conservation of energy, so we can say initially it has kinetic energy. So it has only initially kinetic energy half m1 v0 square. And in the end it will have both kinetic energy as well as its potential energy. मान लो it will raise up to a height h. So we can say one thing, it is half m1 into v0 square. This is half m1 into v square plus half m2 into v square plus m1 into g into h. Right? So this type of equation will become for the conservation of energy and the conservation of, that is initial kinetic energy will be equal to the, that is the kinetic energy plus potential energy. So it is a half m1 v square v0 square, it is half m1 into v square plus m2 into v square plus m1 gh. Right? Now what is the conservation of momentum if we do? If we do the conservation of momentum, तो क्या इक्वेशन बनेगा? देखो, initially the mass m1 is moving with v0, so we can write m1 into v0 and at the end both are moving with v, so m1 plus m2 into v. So what is the value of V? V is M1 divided by M1 plus M2 into V naught. If V is that much, so we can put the value of V there to calculate the value of other, that is the H, right? If you calculate the value of H, you can easily calculate from there, right? So this is the value for the H that you want. Clear? Yes, write down it. Yes, next. A bob of mass 100 gram is released from a position making an angle theta. From vertical. When it is at bottommost point, it takes an extra mass a mass of 100 gram. First, calculate mu maximum height reached by bob if length of string connected to bob is 2 meter. This is the case. It is released from this position but when it reaches at the bottommost position, it gains the mass 2m. There is one more mass there. This is m, this is also m. Now, when it connected to it, when it reaches there, it will gain the mass 2m. It will become 2m. Initially, the mass is m. When it reaches at this position, it has some velocity v, and it will collide with the other mass, that is m, and reaches at some other position, that is theta. We have to calculate this. Now, if we consider this point as A, this point as B, this point as C. The first thing, when it is at this position, so its velocity is 0. And when it reaches at the bottommost position, it gains some velocity v. So you can say by conservation of energy, A to B में, by conservation of energy, initially it has the potential energy. If we take it as reference, it is reference. It has just potential energy. How much is the potential energy? You can calculate it. That is the height from there. What is the height from there? That is L minus L cos theta. That is L minus L cos theta. So we can say M into G into H. H is how much? L minus L cos theta. Cos 60 is 1 by 2. So L minus L cos 60. It is equal to half mv square. So it will become what? M and M will cancel out. It will L minus L by 2 is equal to L by 2. So G into L by 2. L is 2 meters, so it will be 1. It is equal to half V square. So V is equal to root 2G. So it moves with root 2G meter per second. So it travels with the root 2G meter. ये V से आएगा. But when it collides with this, तो उस टाइम पर क्या होगा? Basically it is like this. It is M. It is moving with V. And when 2M, it will become 2M. It is moving with some speed V1. So with the V1 speed, it will start rising. Right? So you can say by conservation of momentum between these two, you can say 2M into V1. It is M into V. So what is V1? V by 2. Means it is moving with V by 2. ये V by 2 से move कर रहा होगा, right? If it is moving with V by 2, then it will rise by the angle theta. So you can calculate by the conservation of energy that is B to C by conservation of energy. B to C by conservation of energy. B से C में अगर मैं energy conservation करूँ, तो we will get कि what is the kinetic energy, it will convert into potential energy. So we can say half 2m into V1 square. It is equal to potential energy. It is how much gain? 2m into G into L minus L cos theta. This 2m will cancel out. And what is V1 square? V1 is V by 2. That is root 2G by 2. That will become how much? That is squaring करेंगे तो it will become 2G by 4. 2G by 4 into this is 2G by 8. तो G से G भी cancel होगा. It will become 2G by 8. That will become G into L into 1 minus cos theta. G से G cancel. That will become G by 1 by 4. L is 1. 1 minus cos theta is 1 by 4. So cos theta is 3 by 4. Cos theta is 3 by 4. From there you will get the value. That is answer is cos theta is 3 by 4. It will be basically maximum height you can calculate from there. Is it clear? Otherwise this is the maximum height L. This is the maximum height H1. वो हम डायरेक्टली ऐसे निकाल सकते हैं. Is it clear to all of you? So in this way we can solve this type of problem. Next. Next is give the heading collisions. देखो, what is collision? It is an interaction between two masses for a short time interval. During collision, the masses may be in contact The next is, so this is the collision. जैसे we can say a lot of examples are there for the collisions. Now I am defining one new term for it, line of impact. Or line of collision. It is a line joining two masses and perpendicular to point of contact. It is a line passing through two masses like these are the two masses. It is before collision moving with U1 and U2. And the collision will occur during collision. It looks like this. So during collision at the point of contact, the normal drawn at the point of contact, this is called line of impact. Line of impact or line of collision along with the force will act during the collision. Is it clear? So this is called the line of impact or line of collision. This is the point of contact. Clear है? लिखो इसको. Yes, next. Next is the types of collision. केस देखेंगे, टाइप्स ऑफ कोलिजन। First is on the basis of energy. First one is the elastic collision. Elastic collision, देखो, it is a collision in which there is no loss of kinetic energy and bodies recover reform fully after collision. Right? Next is inelastic collision. It is a collision in which body lost its kinetic energy and partially regain their original shape. The next is a perfectly inelastic collision. It is a collision in which maximum loss of kinetic energy occurs maximum loss of kinetic energy occurs and bodies stick to each other after collision. Right? So these are the three types of collision on the basis of energy, that is the elastic collision, inelastic collision and perfectly inelastic collision. इलास्टिक कोलिजन में क्या होता है, जब दो बॉडीज टकराती हैं तो टकराने के बाद वो अपनी ओरिजिनल शेप को रीगेन कर लेती है, साथ में उसमें लॉस इन काइनेटिक एनर्जी जो होता है वो जीरो होता है. दूसरा है हमारे पास इनइलास्टिक कोलिजन। उसमें क्या होता है, जब दो बॉडीज कोलाइड करती है तो वो अपनी शेप को रीगेन नहीं कर पाती। जब दो बॉडीज कोलाइड करती है तो इट इज नॉट एबल टू रीगेन इट्स शेप perfectly, but it will regain its shape somehow partially, due to which उनके अंदर कुछ डिफॉर्मेशन भी रह जाता है एंड C1 सब कुछ काइनेटिक एनर्जी का लॉस भी होता है। बट व्हेन वी डिस्कस द परफेक्टली इनइलास्टिक कोलिजन, उसमें लॉस इन काइनेटिक एनर्जी मैक्सिमम है, साथ में दोनों बॉडीज टकराने के बाद स्टिक हो जाती है, दोनों बॉडीज टकराने के बाद स्टिक हो जाती है, राइट। नेक्स्ट इज ऑन द बेसिस ऑफ लाइन ऑफ कोलिजन। Direction of speed of bodies। देखो जिसमें फर्स्ट है दैट इज द ऑब्लिक कोलिजन। It is a collision in which direction of velocity of bodies after and before the collision doesn't remain same। ऑब्लिक कोलिजन के अलावा अनदर वन इज वन डायमेंशनल कोलिजन। It is a collision in which velocities of body just after and before remains same। Direction remains same। So this type of collision is called what? One dimensional collision or 1D collision। So there are two types of collision on the basis of direction of velocities। Like oblique collision, you can say if the two bodies are moving in this direction and these two will collide, and after the collision u1 will start moving in this direction, some velocity v1, and it will start moving in this direction with some velocity v2. So this type of collision, you can say it is a oblique collision, and in this collision is what is occurring. It is moving with u1. Its direction of velocity doesn't change, it is not random, it will move like this. Remain same, right? Here, of course, after the collision, here u1 is greater than u2, and here it is v1, v2 is greater than v1. So this is the thing here. मतलब इन दिस टाइप ऑफ कोलिजन्स हम ये कह सकते हैं कि हमारे पास अगर लाइन ऑफ इम्पैक्ट सेम रहे तो हम कह सकते हैं कि इफ द वेलोसिटीज आर अलोंग द लाइन ऑफ इम्पैक्ट बिफोर एंड आफ्टर द कोलिजन देन इट इज कॉल्ड 1D कोलिजन, बट इफ इट चेंजेस देन इट इज कॉल्ड द ऑब्लिक कोलिजन्स. इज इट क्लियर? यस. वन मोर पॉइंट यू कैन राइट कि जो हमने लास्ट में 1D कोलिजन डिफाइन किया है, जो हमने 1D कोलिजन डिफाइन किया है, यू कैन ऑल्सो से दैट 1D कोलिजन इज द हेड ऑन कोलिजन. तो यू कैन राइट देयर कि जो हमने वहां पर 1D कोलिजन लिखा है उसको हम आप स्लैश डालकर वहां पर ये भी लिख लो कि 1D कोलिजन को हम हेड ऑन कोलिजन भी लिख सकते हैं, उसके ब्रैकेट में लिख लो हेड ऑन कोलिजन. मतलब यू कैन राइट कि जो हमने लास्ट डिफाइन करा है 1 डायमेंशनल कोलिजन, उसके लिए तुम ये भी कर लो डिफाइंड एक चीज, उसके ब्रैकेट में ही हेड ऑन कोलिजन्स. यस, ये उसका एक और नाम है हेड ऑन कोलिजन, राइट? ये आप लिख लेंगे इसके अंदर. नेक्स्ट टर्म आई एम डिफाइनिंग नाउ, इट इज द कोएफिशिएंट ऑफ रेस्टिट्यूशन. That is E. So now I am defining the coefficient of restitution. Yes, लिखेंगे क्या? It is a ratio of impulse of recovery to the impulse of deformation. It is the ratio of impulse of recovery to the impulse of deformation, you can say. देखो इसका मतलब क्या है? मतलब E is defined as impulse of recovery to the impulse of deformation. देखो यस, जैसे इसको हम कैसे डिफाइन कर सकते हैं? There are two masses M1 and M2. It is moving with U1, it is moving with U2 before collision. Of course, before collision, U1 is greater than U2. And during collision, that will occur. And both will start moving with V. मतलब it will impulse of deformation will occur. And both will start moving with V1 and V2. Then V2 is greater than V1, right? So you can say, what is the impulse of deformation? First, by conservation of momentum, we can say कि m1 into u1 plus m2 into u2, it is equal to m1 plus m2 into v. Because during collision there is no external force is acting, only the single force is acting, that is the internal forces. So what is V? Or you can also write it as like this, कि from this to this, कि m1 v1 plus m2 v2 is m1 plus m2 into v. You can also write कि v is m1 v1 plus m2 v2 by m1 plus m2. सही है? Now, if we want to calculate impulse of deformation for m1, अगर मैं m1 के लिए निकाल रहा हूँ impulse of deformation, impulse of deformation देखो क्या होता है, deformation होता है basically impulse होता है that is change in momentum. So what is the impulse of deformation? It is moving with v and it is moving with u1, that is m1 into v minus u1. And what is the impulse of reformation? m1 into, that is v2 minus v, v1 minus v. क्योंकि रिकवरी तो वहां से वहां तक हो रही है ना, that is the reformation stage. Similarly, अगर मैं m2 के लिए लिखूं, if I write for m2, for m2, what is the impulse of reformation? Deformation. That is m2 into v minus u2. And what is impulse of reformation? m2 into v2 minus v. Right. So these are the impulse of deformation and impulse of reformation here. Now, व्हाट इज ई, लाइक ई लिखने जा रहा हूं, दैट इज इम्पल्स ऑफ रिफॉर्मेशन. इम्पल्स ऑफ रिफॉर्मेशन मान लो मैं m2 का लिखता हूं, दैट इज v2 माइनस v. व्हाट इज इम्पल्स ऑफ डिफॉर्मेशन, दैट इज v माइनस u2. Put the value of v there. When you put the value of v there, from there you will get it is v2 minus v1 by u1 minus u2. This is basically velocity of separation by velocity of approach. This is called velocity of separation by velocity of approach. E. The new definition for the E. Along line of impact. These separation and approach velocities are defined along line of impact. Correct. So these are defined only along the line of impact. So this is the thing. मतलब यहाँ तक हमने ये कंक्लूड कर लिया है कि जो कोलिजन होता है इट इज द इंटरेक्शन बिटवीन द टू बॉडीज फॉर अ वेरी शॉर्ट इंटरवल ऑफ टाइम. और कोलिजन के दौरान क्योंकि सिर्फ उन दोनों बॉडीज के बीच में इंटरनल फोर्स लगती है तो उन बॉडीज का के ऊपर कोई पूरे सिस्टम के ऊपर कोई एक्सटर्नल फोर्स नहीं है, तो हम ये डायरेक्टली कह सकते हैं कि उन दोनों बॉडीज को लेकर जो हमारा मोमेंटम रहेगा वो कंजर्व रहेगा. फिर उसके बाद हमने डिस्कस किया दैट इज अ टाइप ऑफ कोलिजन्स. टाइप ऑफ कोलिजन्स में हम कह सकते हैं कि उससे पहले हमने डिस्कस किया लाइन ऑफ इम्पैक्ट. लाइन ऑफ इम्पैक्ट क्या होता है, इट इज अ नॉर्मल ड्रोन पासिंग थ्रू द टू बॉडीज एट द पॉइंट ऑफ कॉन्टेक्ट. उसके बाद हमने डिस्कस किया दैट इज द टाइप्स ऑफ कोलिजन, दैट इज ऑन द बेसिस ऑफ एनर्जी. दीज आर थ्री टाइप, दैट इज द इलास्टिक, इनइलास्टिक एंड परफेक्टली इनइलास्टिक. एंड ऑन द बेसिस ऑफ नेक्स्ट वी हैव डिस्कस्ड दैट इज द डायरेक्शन ऑफ वेलोसिटी. It can be head-on collision or one-dimensional, or it can be another one is oblique collisions. उसके बाद we have defined the coefficient of restitution. The coefficient of restitution is defined along the line of impact. It is basically the velocity of separation by velocity of approach along line of impact. Is it clear to all of you? वैसे हमारे पास इसकी impulse of recovery by impulse of this deformation. इसके अलावा हम इसकी डेफिनेशन को इस तरीके से भी एक्सप्लेन कर सकते हैं. Is it clear? इसको लिखेंगे सब लोग प्लीज. यस.